Dr. Robert Mitchell had a problem that was bleeding Google $2.3 million per week. As Senior Director of Cloud Infrastructure, he'd spent 18 months trying to optimize the company's AI processing speeds. Despite throwing resources at the challenge, 12 PhDs from Stanford and MIT, unlimited computing power and cutting-edge quantum research partnerships, the latency issues persisted. Every millisecond delay in processing meant frustrated enterprise clients, slower cloud services, and competitors gaining market share. Amazon Web Services was already poaching clients who couldn't afford the lag. The engineering team had tried everything: neural network restructuring, parallel processing innovations, even experimental approaches using techniques from CERN's particle physics algorithms. Nothing delivered more than marginal 4 to 7% improvements, and those gains vanished under real-world load. Then came the email that would change everything. Subject: Solution to your cloud latency problem from Manila. Robert almost deleted it. Some contractor from the Philippines named Carlo Reyes, claiming he could solve in weeks what Robert's elite team couldn't crack in 3 years. The audacity was almost offensive, but corporate policy required reviewing external proposals, so Robert opened the attachment with a mixture of curiosity and condescension. His first reaction was laughter. The code looked embarrassingly simple. Basic compression algorithms, data flows structured like... Wait, were those traffic routing patterns? And what appeared to be delivery optimization logic integrated into cloud computing architecture? Robert called over his lead engineer, Jennifer Park, a Caltech graduate who'd worked on SpaceX systems. "Look at this," he said, barely containing his amusement. "Some Filipino developer thinks he can solve enterprise-level AI optimization with code that looks like it was written for a food delivery app." Jennifer scanned the proposal, her expression shifting from skepticism to confusion. "This is way too simplistic for our scale. There's no way this handles the complexity we're dealing with. Where's the advanced machine learning, the predictive modeling?" Robert fired back a polite rejection email, explaining that while they appreciated external input, their challenges required sophisticated enterprise solutions, not basic algorithms. He didn't mention that he found the proposal almost insultingly naive. What Robert didn't know was Carlo's background. Carlo hadn't attended Stanford or MIT. He'd learned to code in Manila's internet cafes during power outages, building systems for jeepney dispatch companies, and optimizing motorcycle courier routes through Metro Manila's legendary traffic chaos. In Manila, efficiency wasn't a theoretical exercise. It was survival. A Grab driver who couldn't adapt to constantly changing road conditions went bankrupt. A Lalamove rider who couldn't navigate flooding, political rallies, random road closures, and the beautiful pandemonium of Filipino streets didn't earn enough to feed his family. Carlo had built systems managing millions of unpredictable variables: monsoon flooding that turned highways into rivers in minutes, flash protests blocking major thoroughfares, power outages shutting down traffic lights, and the magnificent chaos of Manila traffic, where lanes were suggestions and 3 cars somehow fit in 2-lane spaces. He'd learned something crucial: not every variable deserves equal processing power. Just like in Manila traffic, where an experienced driver knows instinctively which congested route actually moves faster because of the behavior patterns of other drivers, Carlo's code didn't try to process everything perfectly. It learned to predict what mattered most. His algorithm didn't just calculate optimal paths, it recognized patterns based on real-world chaos, prioritizing frequent scenarios and processing rare edge cases only when necessary. It was the digital equivalent of a seasoned Manila driver who knows that the longer route on the map is actually faster, because the shorter one floods every afternoon at 3 p.m. 3 weeks later, Robert's manager, desperate for results as the board meeting approached, overruled his decision. "Upload it to the sandbox environment. If it fails, we've lost nothing except a few hours. If it works, we're heroes." Robert agreed, confident he'd be proven right by lunch. They deployed Carlo's code to an isolated test server, handling a tiny fraction of real traffic. Robert and Jennifer watched the monitors like hawks, waiting for the inevitable crash or performance degradation. The first hour, Carlo's system matched their current performance. Nothing special, but surprisingly stable for such simple code. Second hour, It was running 4% faster, probably a fluke. By hour 4, 9% improvement. Robert's confidence wavered. It's the small data set. Wait until we scale it to real-world complexity. They scaled it to 10% of actual traffic, then 25%, then 50%. Carlo's code didn't just maintain performance, it accelerated. The system was learning and adapting like a Manila courier who'd memorized every shortcut, knew which roads flooded, understood traffic officer shift changes, and could predict when accidents would clear based on time of day and location patterns. After 48 hours of testing, 34% improvement in latency, server costs dropping by millions monthly, enterprise client satisfaction scores jumping, response times that made their quantum computing experiments look prehistoric. Robert's 3-year, multi-million-dollar project had been outperformed by a Filipino contractor's too simple code in 2 days. The emergency meeting was brutal. Robert's pride was shattered, but the data was irrefutable. The CFO had one question: how much do we pay this guy to never work for our competitors? They flew Carlo to Mountain View first class. In Google's main conference room, surrounded by engineers with prestigious degrees and patents on their walls, Carlo stood before the smartboard in his simple polo barong and explained in his gentle Filipino accent. In Manila, we have this concept called diskarte. It's hard to translate exactly, but it means smart improvisation, street smarts, practical cleverness. When you grow up navigating a city where traffic rules are more like suggestions and you need to get 20 deliveries done before the afternoon rains flood everything, you learn to see patterns that others miss. He pulled up his code on the massive screen. Your system was trying to process every single request with equal importance and maximum precision. But I noticed something. 70% of your cloud processing requests follow predictable patterns. They're like the jeepneys in Manila that always take the same routes during rush hour. Why waste processing power analyzing those deeply every single time? Jennifer leaned forward, her skepticism transforming into fascination. You created a probability-weighted priority system that front-loads pattern recognition. Carlo smiled. In Manila, we'd say I figured out which traffic lights the jeepney drivers will run, which side streets stay clear, and which shortcuts are actually traps. Your AI was being too democratic, treating a simple common request the same as a complex rare one. That's like a Manila driver stopping at every single traffic light, even when the road is empty at 3 a.m. Technically correct, but practically stupid. He continued, my code does deep analysis only on genuinely unpredictable requests, maybe 30% of your traffic. The rest? It recognizes the pattern instantly and processes it using optimized pathways that I built based on millions of delivery routes I optimized in Manila. When you're coordinating 50,000 motorcycle couriers in real time through a city with no reliable traffic data, you learn to build systems that prioritize speed over perfect precision. The room was silent. Then Jennifer started clapping. This is brilliant. We've been over-engineering the solution for 3 years. Robert, to his enormous credit, stood up and extended his hand to Carlo. I owe you an apology. I called your code too simple because I didn't understand it. You weren't simplifying our problem. You were solving the right problem while we were solving the wrong one perfectly. Carlo's algorithm became the foundation for Google Cloud's next-generation infrastructure. But Robert did something even more important. He convinced Google to establish a development center in Manila, specifically hiring engineers who'd built systems for the chaos of Southeast Asian markets. Within a year, the Manila method was revolutionizing multiple Google products. Search algorithms got faster by recognizing that most queries were variations of common patterns. YouTube's recommendation engine became more efficient by applying the same probability-weighted prioritization. Even Google Maps improved by incorporating the street-smart approach to routing that didn't just calculate optimal paths, but predicted real driver behavior. Carlo returned to Manila, not as a contractor, but as director of Google's Southeast Asia Innovation Lab, commanding a salary that made his mother cry with joy. He built a coding school in Tondo, one of Manila's poorest neighborhoods, teaching the next generation that the best algorithms sometimes come not from perfect theory, but from the beautiful chaos of solving real problems with limited resources. Robert kept Carlo's original rejection email framed in his office with a handwritten note below it. Reminder: too simple usually means I don't understand it yet. Dr. Robert Mitchell, humbled engineer. Months later, when the system was processing 60% of Google Cloud's traffic and saving the company over $100 million annually, Robert sent Carlo a message. Your food delivery app code is now running some of the world's most advanced AI infrastructure. My team wants to know, what other simple problems in Manila have you solved that we're still overcomplicating here? Carlo's reply was classic Filipino. Pare, you'd be surprised what you can learn from fixing a jeepney's engine with a rubber band and a Coke bottle. Diskarte lang. Come visit Manila. I'll show you real engineering. And Robert did. He spent 2 weeks riding in jeepneys, watching delivery riders navigate impossible traffic, and learning that sometimes the most sophisticated solutions come from the streets, not the laboratory. The Filipino who coded like a street-smart courier had just taught Silicon Valley's finest that genius isn't always complicated. Sometimes it's just seeing clearly what others overthink.